Okay, I think we're going to need some zero placeholders for this one. So we have x cubed plus 1 dividing into x to the 5th, and there's no x to the 4ths up there. There's no x to the 3rds, so there's no x squared, and there's no just plain x terms. So we have x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 0x. And finally, a plus 1 on the very end. So, lots of zero placeholders for this problem. Better to put them all in. You never know which ones you're going to need. Often you need all of them. So we start the process now. X cubed divides into x to the 5th, x squared times. Because x squared times x cubed is x to the 5th. And then x squared times 1 is x squared. I'm going to put that over here on the x squared column. Anyway, now we subtract. And the x to the 5ths cancel out. There's nothing here in the x to the 4th, nothing for x to the 3rd. You've got x squared minus 0x squared minus x squared, so that's 0 minus x squared is just negative x squared. We bring down the next term. Well, there's just nothing there. Just put plus 1, because we're done. Because x cubed doesn't divide into negative x squared, so this is the end of the process. And what this shows is that the quotient is x squared, and the remainder is negative x squared plus 1, or 1 minus x squared. I can write that as 1 minus x squared for the remainder over x cubed plus 1. So that's the result of our long division process. And one thing to notice here is that these zero placeholders weren't really needed, were they? But there is no way to really predict that ahead of time. It's better to put them in so that when they are needed, you have a place to put your term. So again, because there are lots of gaps in the denominator as well as the numerator, there were some unused zero placeholders, but it's better to just always put them in case you do need them, because often you do, unpredictably.